Solve problems with geometric sequences. And example 1. A phone call is when one person calls a certain number of people, then those people call the same number of people, and so on. In the fifth round of calls, 243 were called. So A, write an explicit definition to find the number of people called in each round. We already know the explicit definition of geometric sequences is equal with an is equal with a1 time r, the common ratio, in exponent n minus 1. So we already know this. But now here, as we see from the figure how many people they are calling, it says in each round they call the 3 people, each person. So the a1, so the first term started with the a1 is equal to 3. And what do we have else? Else we have in the fifth round a5 is equal with 243. But 243. But what they are not giving us, they are not giving us the common ratio. Common ratio is missing. So, and now we are plugging here. Instead of an, we are plugging a in a fifth. A in a fifth is equal with a1 time r in exponent 4. Now let us substitute those values. A fifth is 243. 243. We already know. R a1 we already know is a 3. R we don't know what it is. And we know here is in exponent 4. What we have to do here first, let divide everything by 3. And we get 81. If we divide everything by 3 here and 3, divide by 3, I'm sorry. Divide by 3. And if we divide 243 by 3 is 81. And the right side, if we divide by 3, remains just r in exponent 4. R is in exponent 4. So we don't have enough space here. Let's go to the next page. We already had 81 is equal with r in exponent 4. So this is a little bit easy numbers, good numbers, because we are looking for 81. We know 9 square is 81. But 9, 3 square is 9. 3 square and everything in square is a 4. So 81 is equal with 3 in exponent 4. 3 in exponent 4. What does it mean? It means that r is equal with 3. So this is easy way. Sometimes when we have good numbers, but when we don't have good numbers and we have a situation like this, let's assume we don't know what's going on. And we have 81, we don't know how to solve it. So we have r in exponent 4. And here we can use logs. Exponential form we can convert into the log form. When we are converted into the log form, now the base become a base of the base of exponent become a base of the logs, and we have a log base r of 81 is equal with 4. But still here we have a work to do in order to solve it for r. No, it gets more complicated. But what happened here, now we can change the base. To change the base, we write with the common logs. Common log of 81 divided by common log of log r. Common log of r. And in this case, this is equal to 4. And here goes a little bit a longer process because we have to multiply everything by log r, both sides, then divide them by 4 and solve it for log r. But one easy way to do it, we just change in the places of 4 with a log r. If we change the places 4 with a log r, we get a log r, log of r, common log of r, is equal with the log of 81, common log of 81 divided by 4. So this is a little bit better, by 4. And now this gives our numerical value. If we use in a calculator, we get some number, some decimal number or something. But we know this is a base 10. And if you want to make a little bit to look more sophisticated or more fancy way, or we can change into the exponents. And we know this is a common log of base is a 10. And this 10 we can write like this 10. And this gets an exponent. What means is going to be a log base 10 of 81, or common log of 81, divided by 4. So it is a numerical value. When it is numerical value, we just plug in a calculator, and the calculator will give us 3. So you can verify at home this result. It doesn't give you the 3, but just to make sure you are calculating right. So now in a B, how many people were called in the 8th round of the phone tree? Let me change a little bit color in this place. How many people were called in the 8th? So in the 8th round, so let's make the term n is equal to the 8. And this is equal A1. A1 was, let me write A1, time r in exponent 7. So because this exponent is 1 less than the term. So a in exponent 8 is equal, now we are substituting those known values. A1 we already have, it was 3. But again, the common ratio is 3. And it's in exponent 7. Just let me look like a 3. And then when we are multiplying, r in 1 is here. And a in 8 is going to be equal with the 3 in exponent 8. And when you calculate in your calculator, the 8th round, so you can verify this result very easy in calculator. And I'm not going to use a calculator here. Is going to be 6,561. So you can use in calculator and you can verify this result. So what does it mean when this phone call was called in every 3 people? In 8th round, they were called 6,561 people.